So here we are going to discuss about the refrigeration and air conditioning plant. So we will be discussing the experimental setup here. And here we are having an evaporator. Then comes the compressor. After compressor comes the condenser, and from the condenser it will be passing through this expansion valve. And here, if you are to find the COP of the system, we will have to find the heat absorbed and work of the compressor. So what we do is we'll be switching on the main supply by plugging this in. We will be switching on the main supply. After that, this is the mains of this particular setup that have to be switched on. Then these two fans represents the fans of condenser fan and the evaporator fan. That is, air sucks the fan sucks the air, and air passes through this particular condenser, and what happens is this air will be taking heat from the working fluid. So those two fans must be on. Then after that, this is the main valve. So by opening it, we can control, by using it we can control the this refrigerant passing through this particular system. So while doing this experiment, we must be aware of keeping the mass flow rate in between 20 and 30. So we will adjust that particular valve and we will keep the mass flow rate in between 20 and 30. So after doing it, after that we can switch on this one. So this one is for condenser. This one is for evaporator. So we will be switching on that. No, this one is for compressor. So we will be switching on that. Then there are 4 places where we should keep the thermometer. So first one, it is T2. So here we will keep a thermometer, and the pressure of that corresponding place will be T2 is the inlet to condenser. So the temperature of the working fluid before entering the condenser, and the pressure will be not from these two, from this thermometer and this dial gauge. Then after that, after the condenser, we will be measuring the temperature by using this port here. This is denoted as T3. We will be keeping a thermometer here, and we will be getting a temperature, and the pressure can be obtained from this dial, which is denoted by P3. So then after that, it flows through this mass flow rate. Then it passes through this expansion valve, and here it is the inlet to evaporator. So at the inlet to evaporator, there is a particular point T4. So at T4 we will be keeping a thermometer, and we will be having the pressure at that particular point from this dial. Then working fluid enters into this evaporator, and after the evaporator we have again the point T1 on point 1. At point 1 we can measure the temperature T1 by keeping a thermometer here, and then we will be having the pressure by this dial. So now after switching on it, we will be waiting for some time so that the system reaches the steady state. So after the steady state, we can obtain the temperature and pressure, and by using this temperature and pressure we can again use this enthalpy, temperature enthalpy diagram, and then we can obtain this enthalpy or pressure and pH diagram. From pH diagram we can obtain the enthalpies on state 1, 2, 3, 4. So here before entering the compressor we are having the state 1, and after the compressor we are having the state it's 2. So if we are having the enthalpy at 1 and enthalpy at 2, then H2 minus H1 will give us the work. And also here the refrigeration effect can be obtained by, here this is the point 4, that is enthalpy before entering into the evaporator, and this is point 1, enthalpy after coming from the evaporator. So here H4 minus H1 or H1 minus H4, we can get the evaporating effect, or we can get the heat absorbed from the surrounding, or heat absorbing from the body which have to be cooled. So H1 minus H4 is the refrigerating effect, and this H2 minus H1 is the compressor valve. So H1 minus H4 can be divided by this H2 minus H1. We will get the COP of the system. That's all about the experimental refrigeration and air conditioning plant. Thank you.